What's up, everybody? This is Danny Mathematics again with another example to explore. And today, guys, I want to go over example 1 of projectile motion and regression. Okay? So in this particular situation, guys, there's a guy named Larry, and he throws a rock in the air, right? The height, which is represented by h, is represented in feet above the ground. And the equation of the projectile motion is the height, which is h, equals negative 16 t squared plus 123t plus 40, right? Now, the question is, guys, that they want to solve is when will the rock hit the ground, right? And the ground is, of course, the height is 0 feet, right? So they want to know, guys, how many seconds will it take, right, for the rock to be thrown and to hit the ground, right? Which, as you can see in this illustration right here, guys, this is Larry, okay? The rock that he has in his hand is 40 feet above the ground. So because that right there is the y-intercept, which is plus 40. So apparently he's standing on a platform as he throws the rock, right? And the rock is 40 feet above the ground, okay? So once again, guys, we're gonna figure out, guys, how many seconds it will take for this rock to be thrown, right? And to follow this projectile motion all the way to the ground, okay? So the first thing, guys, that we need to do, guys, is, once again, if the ball is gonna, or not the ball, if the rock is gonna hit the ground, guys, if the rock is gonna hit the ground, then it's gonna be at the height equals 0 feet. So step 1 is we're gonna set the height, which is h, and we're gonna make it equal 0 feet. And we're gonna plug that into the equation. So the equation is now 0 feet equals negative 16 t squared plus 123t plus 40, right? And for us to find out the time it takes for the rock to reach the ground, right, which is 0 feet, what we need to do, guys, we need to follow the quadratic formula, where t, which is the time, will equal negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, okay? So what we need to do is, guys, we need to figure out what is A, what is B, what is negative B, and what is C, right? Now, these particular values or these variables represent the coefficients of the equation, okay? So the coefficient of t squared is negative 16, and that will be A. So I'm going to set A to be negative 16. So A is negative 16, okay? B, and that's the purple. Let me get my purple marker. Okay. B, guys, is positive 123. So B is 123. And guys, if B is 123, then negative B is negative 123. Okay. Once again, negative 16 is A. And then C is 40. And remember, guys, C is the y-intercept, and it's 40, meaning that the rock was thrown, right? The initial position of the rock was 40 feet above 0 feet, okay? Now, all we're gonna do is, guys, we're just gonna plug these particular values inside of the quadratic formula to find out the time it takes for the rock to hit the ground, okay? So we're gonna start off with negative B. So negative B is negative 123, okay, plus or minus the square root of positive B, which is B squared, 123 squared minus 4 times A. A is negative 16, so it's gonna be 4 minus 4 times negative 16, right, times C, which is 40. All divided by 2 times A. Once again, 2 times A is 2 times negative 16. Okay? So all we need to do, ladies and gentlemen, is to start simplifying the formula, okay? We're gonna need to start simplifying the values that we have, okay? So once again, this stays the same on the outside. We still have negative 123 plus or minus the square root of 123 squared equals 15,129. So 15,129, right? Now, when we multiply in two negatives, that equals a positive, so I'm going to go ahead and put a plus sign. So then -4 times 16 times 40 is 2,560. Is 2,560. All divided by 2 times -16 is -32. Okay? So now we're going to simplify inside of the square root. So we have 15,129 plus 2,560 is 17,689. Okay? So now let me go ahead and rewrite that. So now we have 123, or -123, my bad. -123 plus or minus the square root of 17,689, all divided by -32. Okay? So now we're going to square root that. So the square root of 17,689 is 133. So now, guys, I'm going to actually write this over here. Okay, so now we have -123 plus or minus 133, all divided by -32. Okay, and actually let me make the 123 red so y'all can clearly see what I'm talking about. Once again, the square root of that is 133. So 133, right? Now, of course, guys, there's actually two different operations that we could do. We could do -123 plus 133, right? But that's going to equal a positive, and positive divided by a negative is a negative, right? And there's no way we can have negative seconds. So instead of us doing the plus, we only going to subtract. All right, so I'm actually going to put this. So actually we're going to do -123 minus 133, right? Divided by -32, and I get 8. I get 8. So what it's saying, guys, it will take the rock 8 seconds for it to finally hit the ground from its projectile motion. And this right here would be our final answer, guys. So right here, guys, as he throws the rock and as it hits the ground at 0 feet, at this mark, this is 8 seconds. Right? So it would take him 8 seconds. Okay? So once again, guys, this is example 1 of how to figure out how many seconds it will take something that's being thrown and created a projectile motion to finally hit the ground, okay? So once again, this is example 1 of projectile motion and regression. Thank y'all so much. Tune in next time.